Happy New Year and welcome to the January edition of AJP-Heart and Circulatory Physiology Video Table of Contents, or From the Editor's Desk. Lots to read this month. We've published outstanding science that is incorporated into 25 original research papers, 2 reviews, an editorial focus, and 1 letter to the editor. So I'm ready to dive in, so here's a little sample. Review by Mapanga and Aesop. The damaging effects of hyperglycemia on cardiovascular function are discussed. The focus of this review is on hyperglycemic activation of non-oxidative glucose pathways such as the hexaamine biosynthetic pathway, advanced glycation end products, and protein kinase C. The authors discuss potential new therapeutic targets for cardiovascular disease. Yu et al. Investigated the role of hypoxia on the regulation of vascular MIR 124 and 141 in a post-hemorrhagic rodent model. These 2 mRNAs altered vascular and smooth muscle reactivity and expression of RhoA and RAC1 after hypoxia. These studies also showed the mutual interaction of MIR 124 and 141 on the regulation of RhoA and RAC1 by the transcription factors EGR1 and NERF2. Abwaney and co-workers studied the role of endogenous angiotensin 1 through 7 and the mast receptor pathway and nitric oxide on pacing post-conditioning cardioprotection, or PPC. In a model of ischemia reperfusion injury, PPC mediated improvement in cardiac function and hemodynamics. Infarct size and eNOS phosphorylation were attenuated upon treatment with a mast receptor antagonist or with L-NAME. Ang 1 through 7 also reduced infarct size. These data provide insight into the mechanisms of PPC in that they involve the mast receptor pathway and eNOS. Important review by Chappell. Concerns are raised about the proper way to measure components of the renin-angiotensin system. Here, a critical assessment of current biochemical approaches to characterize and define the various components that reflect the status of the renin-angiotensin system is elaborated. The wide range of techniques used may be reflective of the difficulty in reproducing experimental data by various laboratories in this field. Orga et al. Tested the hypothesis that early upregulation of cardiomyocyte stromal-derived factor CXCR4 could evoke cardiac repair post-myocardial infarction. The effects of HIF hydroxylase inhibitor dimethyloxyglycine, DMOG, on CXCR4 expression were examined. DMOG injection into the border zone increased cardiomyocyte CXCR4 expression at 15 hours in control mice, but not in cardiomyocyte CXCR4 null mice. There was an increase in myosin-positive area in treated mice, but none in the null mice. These data suggest that engagement of the stromal-derived factor 1 CXCR4 axis through the early upregulation of cardiomyocyte CXCR4 is a strategy for improving cardiac repair after MI. Mukoda and colleagues assessed the interaction between PPAR gamma and inflammation by using a model of IL-1 beta-induced aortic dysfunction in transgenic mice with endothelial-specific overexpression of either wild-type or a dominant negative PPAR gamma. IL-1 beta activated the NF-kappa B pathway and reduced endothelial-dependent vasorelaxation. The impaired response to acetylcholine was partially restored by overexpressing PPAR gamma in endothelium or treatment with rosiglitazone. A P65 inhibitor did not reverse the endothelial dysfunction. Additional experiments indicated that oxidative stress mediated in part the reduced vascular responsiveness. The authors conclude that PPAR gamma protects against IL-1 beta-mediated endothelial dysfunction, the reduction in oxidative stress, but not by a blunted IL-1 beta-mediated NF-kappa B pathway. Thank you for watching the January installment of AJP's video table of contents. Remember, as of now, there is no longer a submission fee for manuscripts, so send us your best work. Don't forget to follow us on Facebook and Twitter. Have a happy and prosperous New Year's with lots of discoveries.